Namaste everyone. Here I am going to show relationship between zeros and coefficients of a polynomial. First of all, try to understand about a linear polynomial. As we know, ax plus b, where a is not equal to 0, is a linear polynomial in which a, b are arbitrary constants and x is variable. Its degree is 1, so it is a linear polynomial. As we know, its 0 is the value of x, which will make this polynomial px is equal to 0. X is equal to minus b by a. It is minus constant term by coefficient of x. X is variable, its coefficient, that is a and b. B is constant term with negative symbol. So 0 of a linear polynomial x is equal to minus constant term of polynomial, which is divided by coefficient of x, variable x. Now I am going to take an example of quadratic polynomial. As we know, px, suppose there is a quadratic polynomial as 2x square plus minus 8x plus 6. First of all, we have to find its zeros. Here degree is 2, maximum degree is 2, so it is a quadratic polynomial. We have to find its zeros, and it is easy to find with help of factorization. So its factorization will be like this: plus minus minus. We can split minus 8x as 2x minus 6x plus 6 as minus 2x minus 8 minus 6x, that is minus 8x, and 2 6 is 12, 2 6 is 12, 2 6 is minus minus plus 2 6 is 12. Now 2x is common, then we have x minus 1. 6 is common, then we have x minus 1. In this way we have x minus 1. Here 2x minus 6 is equal to, from these terms 2 is again common, 2 into x minus 1. Now we have here x minus 3. Now x minus 1 and x minus 3, these are two factors of this given polynomial 2x square plus minus 8x plus 6. We can get zeros with help of this. X minus 1 is equal to 0 or x minus 3 is equal to 0. When x minus 1 is equal to 0, then x is equal to 1. When x minus 3 is equal to 0, then x is equal to 3. Two zeros are obtained. This is quadratic polynomial. Degree is 2, so maximum number of zeros will be 2. Suppose this is alpha and this is beta. Now sum of zeros, it means alpha plus beta, it will be 1 plus 3, that is 4. Now we have to relate this 4 in given polynomial, in given quadratic polynomial. 4, we have to obtain 4 from this. We can write like this, minus 8 by 2, and it is minus 8. Minus 8 is this part. Minus 8 is this part. Minus, we can write it as minus coefficient of x. Minus 8 is coefficient of x by 2. 2 is coefficient of x square. Coefficient of x square. Now alpha into beta, product of zeros. Product of zeros will be 1 into 3, that is 3. Now we have to relate this 3 with the given quadratic polynomial, that is 2x square plus minus 8x plus 6. With help of these two terms, we can find 3 as 6 by 2. And this 6 is constant term. Constant term by a. This 2. This is coefficient of x square. Constant term by coefficient of x square. This is the relation between zeros and coefficients of a particular polynomial. This one is a particular polynomial, that is 2x square plus minus 8x plus 6. Now I am going to generalize it. I am going to relate this for a general polynomial. As we know, ax square plus bx plus c is a general polynomial, as ax square plus bx plus c, where a is not equal to 0. A is not equal to 0. As we know, this is a quadratic polynomial, so it will have maximum 2 zeros. Suppose these zeros are alpha and beta. With the help of these zeros, we can find its factors. If alpha and beta are its zeros, then x minus alpha and x minus beta are its factors. Then we can write it with the help of factors as x minus alpha into x minus beta. Here constant term a is coefficient of x square, which is arbitrary constant, but here constant is hidden, so we put here k in place of constant. Now we can solve it like this: k x minus alpha into x minus beta, it will give us as x square minus alpha plus beta x plus alpha beta is equal to k x square minus k alpha plus beta x plus k alpha beta. Now x square. Both are same, so a will be equal to k, implies that k is equal to a. From this, minus k into alpha plus beta is equal to here x is same, so it will be equal to plus b or b. From this, alpha plus beta is equal to, now we have to transpose this minus symbol, minus b by a minus b by k, and again we know that minus b and k is equal to a. We can write it as minus b is coefficient of x is equal to minus coefficient of x by a. A is coefficient of x square. Coefficient of x square. In this way, alpha plus beta is equal to minus coefficient of x by coefficient of x square. Now, k alpha beta is equal to c. K alpha beta is equal to c. From this, alpha beta is equal to c by k is equal to c by a. C is constant term. A is coefficient of x square. Constant term by coefficient of x square. In this way, alpha plus beta, this is same. Constant term by coefficient of x square. Constant term by coefficient of x square. Here also alpha plus beta, sum of zeros is equal to minus coefficient of x by coefficient of x square. Sum of zeros minus coefficient of x by coefficient of x square. And product of zeros, alpha into beta, that is constant term by coefficient of x square. Here also product of zeros is equal to constant term by coefficient of x square. This is particular relationship between zeros and coefficient of a particular quadratic polynomial, and this is relationship between zeros and coefficients of a quadratic polynomial. This is general relationship. That's all. Thank you very much for watching.